In section 2 of chapter 3, we have the weighted mean. The weighted mean of a set of numbers, x1, x2, etc., with corresponding weights, w1, w2, etc., is computed with the following formula. X bar sub w equals the multiplication of each weight and value of x. You add them up and divide it by the summation of the weights. Actually, we with the computation of the mean, we do that too. And I will show you that in a moment. As an illustration of the weighted mean, for example, the Carter Construction Company pays its hourly employees $16.50, $19, and $25. There are 26 hourly employees. 14 are paid $16.50, 10 are paid $19, and 2 are paid $25. What is the mean hourly rate paid for the 26 employees? So notice that if you calculate the average, normally you will add 16.50, 19, and 25, and you divide that by 3. You can do that here. This is my old example from the previous section, which I'm going to use in a moment. So if you calculate the average in that illustration, 16.50 plus 19 plus 25 divided by 3, that is the way the average is calculated normally. And that is, I think it's, the numerator is 1650 divided by 3, which is 20.17 approximately, 20.166. And however, this is not an accurate mean, because not everybody is being paid the same way. 14 are paid 16.50, 10 are paid 19, and only 2 are paid 25. So the wage of $25 is less important than the other two wages. So that's why you take the 14 as a weight and multiply 14 by 16.50 as shown here, and then add 10 times the 19 wage, and then add 2 times the 25 wage. And then in the denominator, you add the wage, 14, 10, and 2, okay? Then the numerator, you get 471, the denominator 26, which is equal to $18, 18.11. So 18.11 is not the same as 20.17. Notice that is lower. So a better measure of the mean in this case is the weighted mean, which is lower than the normal average that we calculate, because these wages are not equally important. The 25 is less important than 26, than 16.5 and 19, and that's why the weighted mean is actually less. So what happens is when you add the three numbers, like we did in the previous section, and divide by 3, this is the equivalent to do this. 1 times 3, notice that I'm using the weight of 1, plus 1 times 7, plus 1 times 11. And then I add the 3 weights, in this case 1, 1, 1. Let me just put this. And notice that that's what we do when we calculate a normal, when we use a normal formula, adding the numbers divided by the number of numbers. We're just using a weight of 1 for each number, and so in other words, we think that each number is equally important. And of course, when we do that, we get the same result of 21 divided by 3, which is 7, okay? And however, as the illustration shows here in the slides, sometimes the values are not equally important. They're not equally weighted. Now, you can also use that for that same approach for you GPAs. Let me erase this. For example, if you take 3 courses and you make an A in one course, a B in another course, and a C in another course, obviously in terms of numbers, these are 4, 3, and 2. And if you calculate your GPA, in this case, normally, without any difference in the weight, you add the 3 divided by 3, that's going to give you 5 plus 4, 9 on the numerator, divided by 3 equals 3. So you think that your GPA is 3.0. However, if this depends on the credit hours. If, for example, this first course is 1 credit hour, this is 1 credit hour, and this is 3 credit hours, then your GPA is actually the weights times the values of each letter grade divided by the summation of the weights. So in this case, it'll be 1 times 4, that is the first course, plus 1 times 3. Notice that I'm putting the weights first, plus 3 times 2. Okay, and then I divide by the summation of the weights, which is 1 plus 1 plus 3, all the credit hours. So that'll be 5 credit hours, 1 plus 1 plus 3. So then when you do that, you get, I believe, in the numerator, to make this as short as possible, the numerator gives you 13. Okay, 4 plus 3, 7, plus 6, 13, divided by 5. Okay, and that is 2.6. So your GPA is actually 2.6, not 3.0. So that is another example of a weighted average. The same applies to the grades. In this course, for example, the syllabus grade is, the syllabus weight is 0.02 or 2%. The Learn Smart, if I'm not mistaken, I think it's 5%. And the homework is 10%. So let me check that out and make sure that I'm correct. I'm opening the syllabus on another page. 2, 10, and 5, yes. So after you take the syllabus quiz, and suppose that your grades are 100 in the syllabus quiz and 90 in the Learn Smart and 80 on the homework. So where your grade just before taking a test, it'll be 0.02 times 100 plus 0.05, the second weight, times 90 plus 0.10 times 80. And now remember, you have to divide by the summation of the weights. So in that case, it's divided by 0.17. 0.02 plus 0.05 plus 0.10. So when you get whatever you get here, that'll be the grade that you have. You don't just add 190 and 80 divided by 3. You need to use the corresponding weights. All right, so that is the end of my coverage of section 2. If you have any questions, again, please contact me.